This is Shakil Ahmed. In this video, I would like to explain about logistic model tree. And that is a type of machine learning model that combines the features of decision tree and logistic regression. It has a tree structure like the model starts by building a decision tree by splitting the data according to certain characteristics that are called features, and then at each node define on each final node we use a logistic regression to predict the outcome instead of just using the mode as we did in a classification and regression tree. So the logistic model tree, for logistic model tree, we need enough data on each node. If we have a smaller number of observation on a single node, then we can't apply the logistic regression on that node. So we start with the Framingham heart disease dataset that is downloaded from Kaggle, and you can also download using the link here mentioned here. And I will just upload the data here on Google Colab using Google Drive. This is Framingham CSV, and I have just uploaded the data here. You will show the data set here, and then we run the pandas. We import pandas and we read the data CSV format data using pd.read CSV, and then dataset name with CSV extension, and then we see the first few observation of the data. For example, if you want to see first 10 observations, you can write this. You can see first 10 observations. Then we do the data pre-processing. We need to check for missing values in outcome as well as in predictors. So what we do, we can check for the missing values, print missing values. This is the title, and then df, this is data frame name, and is null, then sum. So it will sum all the missing values within a column. So for column of education, variable education, we have 105 missing values, and for cigarette per day we have 29 missing values, and so on. So what we do here, we just try to replace missing values with the qualitative variables. We replace missing values with mode, and for quantitative variables we replace them as mean. Although this can be done for a very small number of missing values, but if you have a large number of missing values, then you need to apply certain machine learning algorithms to predict the missing values, and different imputation methods available in literature. So for now, I am just creating two column sets, one quantitative columns and the other qualitative columns, based on the uh, select data type, and then include these two types in this column set, and object type in qualitative column. So it will include qualitative variable columns, and it will include quantitative types of columns. Now we will impute missing values for quantitative columns. We just, if this is missing, any of the values is missing, then we replace it by mean. So mean will be the df column mean. Column means for a certain variable, we compute the mean of the rest of the available observations, and then we are replacing the values with missing cases. And similarly, we are doing same thing by replacing mode with the missing values, and then you can Uh, Again, check for the missing values using the same command as we applied here. So first we need to run this and then this. So now you can see there is no missing values in any of the variable in this data set. Now we will build a classifier that is called a logistic tree classifier. So uh, there are many options you have in Google Colab. We need to install a package that is called Python Weka-based that through this we can use the uh, logistic model tree. So we just install it and then check. And if you are using Anaconda or other software, then you need to install this as well, and you can check for the package before running the commands. And we need to again import the test training split for splitting the data into test and training and test sets, and then accuracy and other performance measures you want. You and then you can split the data into x and y first, and then you split into test and training. So your x data frame consists of all other variables, just excluding the chronic heart disease status, and y is the 10-year chronic heart disease status. So we can just run, and then we will split the data into test and training, keeping 20% in test set and remaining 80% in the training set, and then using a random start with 4 2, and you can just run. And we need I model to fit the model as well. You can just run this. Now we will just from iModels we import the rules fit classifier. So that is basically to fit a regression model on each node after splitting the data into different nodes based on predictors available, and then on each node we fit a logistic regression model. So we are setting a model name as, just we call it model, although you can call it logistic model tree, and then logistic model tree dot fit. And you can always search for help using AI here if you can't understand anything while working with codes. You can search with AI. You can just write your question, and AI will uh, eventually correct your result and so on. So this is now we have just run, and we obtain the coefficients on based for different variables, and then we can now predict the y values for x test, and then y predicted probabilities. We can also see the predicted probabilities for the test set. We need to change this. We name it as logistic model tree. So use also logistic model tree, and then you can run. These are the predicted values. Most of the values are predicted as 0, and these are the predicted probabilities. And now we can again import the accuracy, precision score, recall score. We have already done this. We don't need to do this. So we need to import the performance measures, and then we compute the accuracy score, y test and y predict, precision score, y test and all these things. So you can just run this and then print the all the values. So the accuracy is 85.5%, but the precision is 0 and recall is also 0. And as F1 depends on recall and precision, so it will also 0. So this model is giving a uh, pre good prediction, predicting. This model is good in predicting the zeros, non cases, but it failed to predict at specific cases. So we can also see the confusion matrix. I will show later. So the precision is 0, recall is 0, and F1 score is 0. So this model is not a good approach for this data set. When we have large number of data sets, then we can go with with fewer number of observations and a large number of observations with fewer number of variables. We will prefer the logistic model tree. So you can also see for the uh, performance measures the feature importance using after installing the interpret uh, library from Python. I'm just for now I'm skipping this, and I will just show the confusion matrix and then summarizing this tutorial. So for confusion matrix we need matplot library as PLT and Seaborn, and then we also need the confusion matrix. You can also obtain ROC and ROC score, but for now I am just skipping them. Uh, we have a tutorial on making confusion matrix, making ROC and AUC in previous video. I think logistic regression model. You can see that. And then we generate confusion matrix, and then uh, this is the confusion matrix, and we are making a heat map using confusion matrix, and this is the size of the figure, and we are using FMTSD and a color map as blue, and then these are the ticks name. You can see here these are the ticks, tick names, no CHD and CHD. These are the predicted and these are the actual. So we have just label as predicted and actual. As predicted is on x-axis and actual is on y-axis, and the plot title is confusion matrix. So you can see we have a higher number of predicted zeros as 0 means no CHD as no CHD, but no cases in CHD group was predicted as CHD. That's why the model performance is poor, as the model has failed in predicting the CHD, people with CHD as CHD. So, however, we can improve this by checking the number of variables and removing variables that are causing a smaller number of nodes, smaller number of observation on each node, and we can rectify the model accordingly. And the other option is to go with other type of machine learning tree-based algorithms like boosting, gradient boosting, or adaptive boosting algorithms instead of logistic model based tree. Thank you.